Good morning, dear students. Now let us move on to the last session of this organic chemistry, or the last session of this heterocyclic compounds, that is drugs. Okay. So the word drug, it means the term it means it is dry herb. Okay, it is dry herb. Drug means dry herb. And also there is a definition for this drug. Normally drugs, what do you mean by drugs? They are normally medicines, isn't it? So medicines, we are calling it as, alternatively we are calling it as drugs. So drugs means it is a substance. It is used for the prevention. It is a chemical compound. It is used for the prevention, then diagnosis or treatment of a disease. Used for the prevention or diagnosis or treatment of a disease of animals including man. Okay, so that is what is a drug is defined as. And also another definition for drug is it is defined as a substance with an abnormal effect on certain body functions. Substance with an abnormal effect. Substance with an abnormal effect on body functions. Substance with an abnormal effect on body functions. So some of the examples for drugs, natural drugs or synthetic drugs, some of the examples are morphine. It is a painkiller. Morphine. Morphine, it is a painkiller. Then quinine. It is having anti-malarial activity. That is, it will be acting against, or it will be fighting against and malaria. Okay, so it is anti-malarial, etc. So these are some of the organic drugs, morphine, then quinine, etc. And so much of synthetic drugs are also there. So these are natural organic drugs. These are natural organic drugs. Okay. Then the next is characteristics of drug. See, normally a chemical substance, if it has to be used as a drug, it should have some certain criteria, or it should fulfill some conditions. It is acting upon human bodies, isn't it? So it should be much sensitive also, and it will be acting on different human beings differently. So it should have certain criteria, and it should undergo so many processes, isn't it? So some of the essential requirements for a drug that you have to study is that the first one, see, I will be reading the points, okay, so that you have to study. Okay, I will not be writing these points, you just read the textbook. Okay, so for the time being, I will be reading this. Characteristics of a drug. An ideal drug should satisfy the following requirements when administered to the ailing person or host. Ailing person means the diseased person. Its action should be localized at the site where it is desired to act. However, there is no drug which behaves in this way. That means if we are having a pain, or if we are having a wound in a particular part of a body, then the drug should be acting on that particular site itself. But actually, it is not like that. Most of the drugs will be acting upon the human body, in the total body itself. Okay, so that is the first characteristic. It should be localized at that particular site itself. So that is the first characteristic of a drug. Then the next one, it should not have any toxicity. It should not be poisonous. Then it should have minimum side effects. Then it should act in a system with efficiency and safety. It should not harm host tissues. That means only the diseased tissues or the tissues which are damaged should be treated by this particular drug. It should not damage the other tissues which is healthy. Okay. Then it should not adversely affect any physiological processes. Then it should not make the host cells resistant to the drug after its use for some time. Normally, if we are taking a drug for a particular disease, and after a short time, or after a particular span of time, if we are taking again for the same disease itself, suppose if it is acting, if it is working, it should be okay. Otherwise, if it is not working after the first dose, what happens? That is not a quality of a drug. So once a drug it is acted upon a body, our body should not be resistant. It should not be like that. Okay, so it should not make the host cells resistant to the drug after its use for some time. So these are some of the essential conditions or the characteristics of a drug. Okay, so you have to study the characteristics of a drug and also the definitions. Should not skip this point. This is important, characteristics and definition for a drug. Okay, you have to write it from the textbook, the points you have to read. Then the next is regarding the classification of drugs. Classification of drugs. See, normally drugs, they are classified into two categories. That is, the first one, it is based on the chemical structure. First one based on the chemical structure, and the second one based on their therapeutic actions. Therapeutic actions. Okay, so chemical, normally the drugs which is based on the chemical structure, they are classified into different categories. Usually sulfonamides, it will be coming under this category. Then thiols, thioamides, etc. will be coming under this category. That is drugs based on the chemical structure. Then in the case of the drugs based on the therapeutic actions, so many drugs will be there. Okay, so many drugs are there coming in this based on the physiological actions. And also it is very difficult to give the chemistry of the drugs having certain therapeutic actions. So normally a drug means it will be coming, or it will be in between, or it will be the combination of both these two. That means it will be a combination of chemical structure and therapeutic actions, or it will be a compromise of these two classes of drugs. Okay, it will be a combination, or it will be a compromise of chemical structure and therapeutic actions. Both will be combined in a way to form a particular drug. Okay, without one, that means one is complementary to another one. Okay, without one, the another will not be there. Okay, so both of them are complementary to each other. Then the next is different types of drugs based on the functional aspects. Okay, so functional agents, or based on the functional aspects, we are classifying drugs. Based on the functional agents, we are classifying drugs. And the first category, that is the antipyretics. Antipyretics. See here, antipyretics means normally pyretics, the word pyretics means it will be related to temperature, isn't it? So antipyretics means it will be acting against temperature. So antipyretics means these are drugs used to lower the temperature in the body. Used to lower the temperature in body. And normally, as you know, we are taking paracetamol, isn't it? Paracetamol tablets for lowering the temperature, isn't it? Paracetamol for lowering the temperature. Paracetamol is 4-acetamidophenol. 4-acetamidophenol, that is paracetamol. Okay, then aspirin, it is another example, aspirin. Then the next category, the second one, antipyretic. See, these terms, these types of drugs or these class will be asked for your section B part sometimes. Okay, what do you mean by an antipyretic, or give an example for an antipyretic. Then the next is analgesics. Analgesics means they will be these type of drugs, analgesics, they are used to decrease the pain or relieve the pain. Okay, used to decrease the pain from our body. So they are called as analgesics, and mainly they are of two categories, analgesics. That means the first one, that is the narcotics, and the second one, that is the non-narcotics. See, narcotics means they will be producing a depressing action on the central nervous system. They will be producing a depressing action on central nervous system. That means it will be acting on people who is hyperactive. Okay, so that it will be developing a depressing action on the central nervous system. As you know, central nervous system, it will be as you know, this central nervous system, it will be creating a depressing action on the central nervous system. And also examples for this category of drugs, narcotics, is morphine. These are all you might have heard, isn't it? Morphine, then heroin, then codeine, C-O-D-I-N-E. So these are all narcotics. Okay. Then coming to the non-narcotics category, they are having antipyretic properties. Antipyretic, that means it will be fighting against temperature. They will be having antipyretic properties. Then example, aspirin. Aspirin is acetyl salicylic acid, isn't it? So that is an example. Aspirin, analgin, etc. are examples for non-narcotics. Okay. So two types of analgesics. Analgesics are used to relieve the pain. Two types, narcotics and non-narcotics. One is having a depressing action on central nervous system, and the other one is it is having antipyretic properties. Then the next category, the third one, that is the tranquilizers. Third one, tranquilizers. Tranquilizers. See, these tranquilizers, they are used to reduce anxiety and tension. Used to reduce anxiety and tension. So these again, these tranquilizers, they are again classified into two categories: sedatives. Sedatives, you know, isn't it? Sedatives and antidepressants. Sedatives and antidepressants. See, normally these sedatives, it will be having, sedatives means it will be having a relaxing effect on central nervous system. Okay. Sedatives will be developing a relaxing effect. Normally, if we are consuming sedatives, we will be easily, falling into sleep, isn't it? So, this will be having a relaxing effect on central nervous system. So, that is what is called as sedatives, and this will be causing mild depression. So for those who are hyperactive, this type of sedatives will be applicable. For those, it will be causing mild depression. It will be causing mild depression. Okay. And then some of the examples for this category of drug is Aquanil, ACQANIL, Aquanil. You have to study the examples also. Aquanil, then Brompton. Aquanil, Brompton. Okay. Then coming to the next category, antidepressants. Antidepressants means it will be fighting against depression. Okay, that is antidepressants. So it will be, the main purpose of this drug is, it will produce a feeling of well-being. Produce a feeling of well-being. That is, it will be fighting against depression, and also it will improve efficiency. It improve efficiency. Example, cocaine, 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 then Vitelin, etc. These are some of the drugs under this category, antidepressants. Okay. So this will be, normally this antidepressants, it will be preventing psychic depression. Okay. Prevents psychic depression. Prevents psychic depression. Then the next category, the fourth one, that is hypnotics. Hypnotics. Normally these drugs, it will be inducing sleep. Sleep-inducing medicines, they are coming under this category. They will be inducing sleep. You have heard of this hypnotics, isn't it? Sometimes you might have seen some of the videos also, which is spreading in social medias, right? So some of the examples for hypnotics, that is Luminal, then Seconal. So these are some of the drugs used. Then Chlorton. So these are some of the examples for the drugs used in hypnotics. You might have heard in films also, isn't it? Then the next category, the fifth one, that is the psychedelic drugs. Psychedelic drugs. Psychedelic drugs. And these drugs means they are these type of drugs, it will produce visual and auditory hallucinations. Visual and auditory hallucinations. These drugs produce visual and auditory hallucinations, and example for this category is lysergic acid, LYSERGIC, lysergic acid, then diethylamide, etc. diethylamide, etc. So these are some of the psychedelic drugs. It will be producing visual and auditory hallucinations. Then the next category, the sixth one, anesthetics. Anesthetics, you know, it will be producing insensibility to pains. That means our body will not respond to pains, isn't it? Insensible to pains. It will create insensibility to pains and other sensations. That means that particular part of the body will be relieved from pain, or that particular part of the body will not be sensible to pain. And also this anesthetics, also two types. You might have heard of this: local anesthetics and general anesthetics. Local anesthetics and general anesthetics. Local anesthetics means it will be producing insensibility to pain to a particular part of a body. Okay, to a particular part. Sometimes if we are having a pain in our tooth, what happens? Some medicine will be injected at that part, and that the reason for the pain is removed, isn't it? By using that local anesthetics, isn't it? So for a particular part of the body, this local anesthetics will be applied so that that particular part will be insensible to pain. Okay, so that is the case of local anesthetics. So it is used for small surgical operations. Used in small surgical operations. Only for minor surgeries this will be done. This local anesthesia will be given. Normally for tooth extraction, then stitching of a wound, etc. Okay, so that is the case of local anesthetics. All these you might have heard. And then general anesthetic means it will be producing unconsciousness to the whole part of the body, or it will be producing an unconsciousness. General anesthetics will be developing an unconsciousness and muscular relaxation. And mainly they are used for major surgeries, isn't it? They are used for major surgeries. Example, nitric oxide, then cyclopropane, then ethylene, then divinyl ether, etc. These are some of the examples for this general anesthetic. So two category, local and general anesthetics. Okay. Then the next one you have to study, that is what are the chemotherapeutic agents and pharmacodynamic agents. Okay, so chemotherapeutic agents. These are all portions you have to read the textbook thoroughly. Okay, I'm just writing the points only for your easy reference. This you have to study the points from your textbook also. See, this therapeutic agents means these are also drugs, and these drugs are used for the treatment of infectious diseases. Okay, used in the treatment of infectious diseases. And these infectious diseases, normally these diseases may be caused by the infection due to some bacteria or fungi, or protozoa or virus, etc. Okay, so these drugs will be fighting against this particular category. That means they will be fighting against the infectious diseases, and they will be these therapeutic drugs, or these category of drugs, they will be kill the incoming organism or the invading organism which is present in our body, and thereby treating the person, okay, diseased person. So these drugs will be killing the invading or incoming, we can say. They will be killing the invading organisms, and thereby the diseased person will be freed up from that particular disease. So it will be acting, these drugs will be acting against this category, bacteria or fungi or protozoa or virus. Okay, so normally this category of drugs, they are used for the treatment of diseases like malaria, then tuberculosis, etc. Then again this chemotherapeutic agents, this I'm not writing it again, this therapeutic agents, it can be classified into so many categories. So the first category coming under this chemotherapeutics is organometallic therapeutics. Organometallic therapeutics. Then the second category of this type of drug, that is anti-malarials. If asked for a short note, you have to write all these. Okay, anti-malarials, then antibacterials, then antibiotics. Antibacterials means sulfa drugs will be coming under this category. Then the fourth one, that is antibiotics. Then the fifth one, antiprotozoals. Then the sixth one, antifungals. All are antis, isn't it? Antifungals. Then antiseptics. Then eighth one, anti-tubercular drugs. That means it will be acting against tuberculosis. Anti-tubercular drugs. Then ninth one, anti-leprosy drugs, fighting against leprosy. Anti-leprosy drugs. Then 10th one, antimicrobials. Then 11th one, disinfectants. Then the 12th one, birth control drugs. So these are some of the categories of this chemotherapeutic agents. Okay, so if asked for section C, you have to write all this, because in your syllabus it is highlighted. It is a highlighted part, that is the chemotherapeutic agents. Okay, then the next is pharmacodynamic agents. Next category of drugs, that is the pharmacodynamic agents. See here, this drugs, it will be these type of drugs, it will be helping against a specific bacterial or viral infection. Okay, it will be acting against a specific bacterial or viral infection. Pharmacodynamic agents, these category of drugs will be treating against or will be acting against the specific bacterial or viral infection. And also these drugs will be normally affecting the blood circulation, isn't it? It usually affects the blood circulation. Pharmacodynamic agents, it will be affecting the blood circulation. And also this pharmacodynamic agents means it will be this, how a drug, it will be affecting on an organism, or how it affects the central nervous system. That is what this particular drug will be studying. Okay, and also they are again classified into certain categories. Pharmacodynamics, the word means it is the study of the biochemical and the physiological effects of a drug. Pharmacodynamics. Okay, pharmacodynamics means it is the study of biochemical and physiological effects of drug. That is what is called as pharmacodynamics. That branch it is called It is like this. Okay, so here also this pharmacodynamic type of drugs, they are classified into so many categories. That means the first category, that is which will be affecting the central nervous system, that is they are depressants. The first category of drugs, depressants. Then the second category, they are the selective modifiers of central nervous system, that is the tranquilizers. We have seen what are tranquilizers, depressants, tranquilizers. Then the third one, that is the central nervous system stimulants. Central nervous system stimulants. That is, central nervous stimulants means they are antidepressants, that is fighting against depression, isn't it? They are antidepressants. Then the next one, the fourth category, that is the adrenergic stimulants. Adrenergic stimulants. Adrenergic stimulants. Then the fifth one, that is the cholinergic and anticholinergic. Cholinergic and anticholinergic agents. Then the sixth one, that is cardiovascular. Then anesthetics, antipyretics, etc. Anesthetics, then antipyretics, eighth one, antipyretics, etc. So these are some of the category of this particular pharmacodynamics. Okay, then anticoagulants are there, antihistamines are there, anticoagulants, then antihistamines. Okay, so these are some of the classes of pharmacodynamic agents. Then the next is the central nervous system or pharmacological agents. Pharmacological agents. Pharmacological agents. See here, these pharmacological drugs. These are the drugs which are acting on the central nervous system. Okay, central nervous system means it will be consisting of brain and the spinal cord, and this category of drugs, it will be affecting this brain as well as the spinal cord. That means if it is affecting the brain, means it will be affecting the thought processes, isn't it? It will be affecting the, or it will be able to control the thought processes or emotions or senses of human beings. Thought process or emotions or senses or motor functions of human beings. So that is the category of drugs coming under this particular category. So here the drugs will be antidepressants. Just as we saw in the previous case, there will be antidepressants, then antipsychotics, then anxiolytics means those drugs which will be reducing anxiety. Okay, those drugs which reduces anxiety. So these are some of the category of drugs coming under this category, pharmacological agents. Then some of the drugs acting on the central nervous system. Drugs acting on central nervous system. They are generally, we have seen so many classes, that means the antidepressants, then analgesics, antipyretics, etc. So those are some of the drugs acting on the central nervous system. Then some others are there, anticonvulsants, antitussives. Antitussives means those will be those medicines or those drugs which will suppress coughing. Okay, those medicines which suppress coughing, they are antitussives. Okay, then that also you have to read, which is given in your textbook. Then the drugs stimulating or blocking the peripheral nervous system. So I will be showing this details. See, the drugs stimulating or blocking the peripheral nervous system. That means some of the drugs, that means this cholinergic and anticholinergic agents, then adrenergic stimulants, then adrenergic blocking agents, inhibitors of catecholamine biosynthesis and metabolism, histamine and antihistamine, local anesthetics. These are all drugs coming under this category, drugs which stimulate or blocks the peripheral nervous system. Okay, you just go through all these. I don't know whether it will be asked. Until now it is not asked, I think, but you have to study this chemotherapeutic agents, pharmacodynamic agents, etc. It's very, very important. This part you just have a read. Okay. Then the next is the category of drugs which is acting on the renal systems. Renal systems means which will be acting on the kidney, etc. Or which these are drugs which affect the cardiovascular function and also act on blood vessels and also the renal system. So cardiovascular agents means it can be cardiotonic, anti-rhythmic, then anti-hypertensive, vasodilator and hypocholesteremic agents. So these are all related to heart. These terms are all related to heart. Cardio, the word itself, it is related to heart. Then rhythmic, if somebody has got an irregular rhythm, this drug will be acting on it. Then anti-hypertensive, vasodilator, etc. Then the drugs acting on the blood, they are called as hematological agents. So they are these hematological agents, these include anti-anemics, coagulants, anticoagulants and plasma expanders. Okay. So and also the drugs which affect the renal system, they are called as diuretics. So these all drugs, this also you have to read. Okay. Then the next is some chemistry regarding the drugs. Okay, you have to study some of the drugs and the action of the drugs. Okay, so first of all you have to study sulfa drugs. Sulfa drugs, some reactions are there and also the reactions are very simple to study. This might be asked for your examination. So sulfa drugs, so these sulfa drugs, they are synthetic chemotherapeutic agents. Synthetic chemotherapeutic agents, sulfa drugs. And also you have to go through one by one the synthesis of this sulfa drugs, and the first one you have to study, that is sulfanilamide. Sulfanilamide, AMIDE. Okay, sulfanilamide. See here, for the synthesis of the sulfanilamide, the starting compound is acetanilide. Okay, acetanilide, that means it is a derivative of aniline, isn't it? C6H5NH, isn't it? NH2 is aniline. So derivative of aniline means one of the hydrogen, it is replaced by this acetyl group, that means CH3CO group. So CH3CONH C6H5, this compound is acetanilide. So for all the drugs coming below, it will be having the starting compound will be acetanilide. So the first two steps will be the same for some of the reactions. Okay, so acetanilamide, when treated with chlorosulfonic acid. Chlorosulfonic acid. So here chlorosulfonic acid, the structure it is like this, ClSO3H. Chlorosulfonic acid. So what happens is that, see, from this position one hydrogen, then one hydrogen, from this one hydrogen, and from this one oxygen atom will be eliminated. Okay, so that one water molecule will be eliminated. So the product will be like this. So the remaining will be SO2Cl, isn't it? The remaining compound will the group will be SO2Cl. So the product will be like this, CH3CO, then NH, then single bond C6H5, then at this point it becomes SO2Cl. Okay, SO2Cl. Then this compound, that is, see, I am writing it again, CH3CONH, then C6H5, then SO2Cl. This compound again on reaction with ammonia plus ammonia, I am writing it as HNH2. So what happens? The elimination will be like this. One HCl will be eliminated, isn't it? Minus HCl. So the product will be CH3, then CONH, then C6H5, then SO2, NH2. Okay, then again on hydrolysis, alkaline hydrolysis in presence of NaOH, what happens is that at this position the bond breaks and this hydrolysis takes place. Alkaline hydrolysis, sodium hydroxide in presence of water, so HOH. So this group will be eliminated as CH3COOH, isn't it? CH3COOH, and here it becomes NH2. So the product will be like this, NH2, isn't it? NH2, then C6H5, then SO2, NH2. So this compound is sulfanilamide. Sulfanilamide, okay. Then the next compound, so this is the synthesis of sulfanilamide. This is very, very important. All these syntheses are very, very important, okay. Then the next compound, that is the synthesis of sulfapyridine. Synthesis of sulfapyridine. Synthesis of sulfapyridine. See here, sulfapyridine, the starting compound is just like the previous case, that is starting with acetanilide, CH3CONH, then C6H5. Starting compound. Then again starting compound on treating with chlorosulfonic acid, ClSO3H. One molecule of water will be eliminated, so that the product will be CH3CONH, then C6H5, then SO2Cl, isn't it? SO2Cl. This compound again on treating with aminopyridine, okay, plus aminopyridine. I am writing it here itself. Aminopyridine means pyridine. First of all, you have to draw the structure of pyridine, and at the second position, amino group. So it is 2-aminopyridine, isn't it? This compound is 2-aminopyridine. 2-aminopyridine. So what happens is that from this position Cl group and from this NH2 one hydrogen, both of them will be eliminated. One HCl will be eliminated. Okay, I am writing in the reverse order. So minus HCl. What happens? The product will be CH3CONH, isn't it? CH3CONH, then C6H5, then SO2. Okay, then SO2, then comes NH, isn't it? Here the bonding. So SO2, NH. So this NH, it is at the second position of this aminopyridine, isn't it? NH. Okay. So this is the compound. Then what is the next step? Just as in the previous case on hydrolysis. So hydrolysis means at this position hydrolysis takes place, alkaline hydrolysis. So here HOH. What happens here? It becomes acetic acid. Here it becomes NH2 group. So we need this particular product. So it becomes NH2, then C6H5, then SO2NH, then this particular compound. Yeah. Okay. So this is the compound and this is sulfapyridine. Sulfapyridine. Okay. So this is the synthesis of sulfapyridine. Just a simple reaction, but you have to remember the starting compound and also the reagents in between. Then the next compound, that is sulfathiazole. 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 Here also the starting compound is acetanilide. Again CH3CONH, then C6H5, acetanilide, then again on treating with chlorosulfonic acid, just as in the previous reactions, chlorosulfonic acid. Then what happens? This one molecule of water will be eliminated and we will be having this particular compound CH3CONH, then again C6H5, then SO2Cl, isn't it? Then this compound on reaction with 2-aminothiazole plus 2-amino-thiazole. So the compound is like this, 2-amino-thiazole. That means S at this position and nitrogen at this position. So here double bonds at these two. Then at this position amino group. So it is 2-amino-thiazole. 2-amino-thiazole. Okay. So what happens again? Again one HCl will be eliminated. That means Cl from this position and hydrogen from this NH2 group will be eliminated as HCl. Okay, minus HCl. So the compound will be like this: CH3, CONH, CONH, then C6H5, then SO2, then NH, isn't it? SO2, NH bonding will be like this: SO2 and NH, then this particular ring. Sorry, it's a 5-membered ring. Yes, this is nitrogen. At this position nitrogen, then double bonds. Okay, so this is the compound sulfa-thiazole. Okay, so this is sulfa-thiazole. Sorry, this we have to hydrolyze, isn't it? Here hydrolysis. Hydrolysis means at this position HOH. So this will be remaining as CH3, COH. Here it becomes NH2, just as in the previous reaction. NH2, then C6H5, then SO2, then NH. You have to write it that particular compound. Then S at this position N, then double bond. Okay, so this compound is sulfa-thiazole. Sulfa-thiazole. Then the next is the mode of action of sulfa drugs. Mode of action of sulfa drugs. Mode of action of sulfa drugs. See here the sulfa drugs. Normally these sulfa drugs, it will be having a structural similarity between with para-aminobenzoic acid. Okay, I'll show you the structure. You have to read the textbook. See, this is para-aminobenzoic acid. At the para position, NH2 group is present, isn't it? And this is a sulfanilamide derivative. So what happens is that while a bacteria is attacking this particular compound, both of them are having structural similarity. So this bacteria can't distinguish between whether it is a para-amino derivative or a sulfanilamide derivative. So what happens is that since the bacteria couldn't distinguish between these two categories, normally this para-benzoic acid it is used for the preparation of this folic acid or for the synthesis of folic acid. So the sulfanilamide, it will be inhibiting or it will be decreasing the bacterial action, while para-aminobenzoic acid, it will be enhancing the bacterial action, or it is used for the synthesis of folic acid. And as a result, what happens? This bacteria, it couldn't distinguish between these two. So what happens? It will be normally the actions of the action of bacteria, or the bacteria will be itself destroyed due to the action of this sulfanilamide derivatives. Okay, so that is the mechanism going on, or the action of this drugs on bacteria, how a drug is acting on a bacteria. So you have to read all these points also, which is given in your textbook. That is the simple thing which is going on. The bacteria cannot distinguish between these two, para-aminobenzoic acid and also the sulfa drugs. Therefore, while it is going on to an action between these two, what happens? It will be destroyed. The bacteria will be destroyed. Then similar is the case of the mode of action of ampicillin. Mode of action of ampicillin. Ampicillin. It's also a drug, and also this ampicillin means it is commonly called as penicillin drug. You might have heard of this penicillin, isn't it? And this it is normally this particular penicillin, it is used to penetrate the gram-positive and gram-negative bacteria. Gram-positive and gram-negative bacteria. This gram test means, this gram test, it is used to classify the bacteria according to their cell wall. Okay, this gram test, it is done to classify bacteria. Gram test, it is used to classify bacteria according to their cell wall. according to their cell wall. Okay, so what happens is that if a positive gram, if the test is gram positive, it will be causing a color change. Okay, so while staining is done, a color change will be occurring if it is a gram positive bacteria. Okay, and also this this ampicillin, it will be differing from penicillin G. It will be differing from penicillin G, also capital G, or benzyl penicillin. And also the structure of this ampicillin, it is also given. See the structure, it is like this. See, C6H5, then CHNH2, CONH, then a cyclic structure, then SCCH3, etc. So this is a pentagonal structure. Okay, so this is the structure of this ampicillin. Okay, then the next compound, that is chloroquine. These are all mentioned in your syllabus, so you should not skip these portions also. You have to study the structure also. Chloroquine, sometimes a structure might be asked. I don't know whether it will be asking on also. Chloroquine, they see the structure. Chloroquine, it is a synthetic anti-malarial drug. Chloroquine is a synthetic anti-malarial drug. Synthetic anti-malarial drug, and also it is a suppressive drug. Suppressive drug. Then it is used for the treatment of malaria. Used for the treatment of malaria. Used for the treatment of malaria. Okay. Then the structure of chloroquine, it is like this. See, this benzene ring, then a chlorine atom, then again the second one, that is a pyridine ring with a nitrogen, then NH, CH, CH3, CH2 thrice, N, C2H5 twice, an ethyl group is there, a methylene group is there, a methyl group is there, then chlorine atom, then nitrogen, then NH group. Okay, so this is the structure of chloroquine. Sometimes the structure will be asked. Okay, so two rings are there with this much groups. Okay. Then the next is paracetamol. 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 The compound is N-acetyl para-aminophenol. N-acetyl para-aminophenol. This, you are familiar with this drug, isn't it? This drug, it is an antipyretic and analgesic. Antipyretic and analgesic. The structure, it is like this: C6H5 OH, then NH CO CH3. This is the drug, N-acetyl para-aminophenol. Okay, at the para position, this OH group is present, then N-acetyl, the linkage of acetyl group, it is through the nitrogen atom. So that is paracetamol. Then the last drug that you have to study here, that is the aspirin or acetyl salicylic acid. Aspirin or acetyl salicylic acid. So aspirin, it is also used as an analgesic. Also used as an analgesic. That means it is used to relieve pain. It can be headache, toothache, or body aches, or anything like that. So, and also it is used as an analgesic. At the same time, it is used as an antipyretic. That means it can lower the body temperature also. Okay, so aspirin, it is used as an analgesic and antipyretic. And the structure of aspirin is acetyl salicylic acid. Okay, so the structure, it is like this: C6H5, then OCOCH3, then COOH. Okay, so this is the structure of aspirin. C6H5 OCOCH3, then COOH, acetyl salicylic acid. This is the acetyl group. Okay, acetyl salicylic acid. So this is the portions of organic chemistry. So organic chemistry portions are over. And also you have to study all these. Sometimes these portions, this after the drugs, it might be after B part. Okay, so you have to study. Please don't skip these portions also. So our organic chemistry and polymer chemistry portions are over. Okay, So you have to study thoroughly. Please don't waste your time. It's my request. Thank you.